Hello and welcome to this video in a series of videos of using quadratic equations to answer word problems. This problem is just one example of a type of problem you would encounter while using strategies involving quadratics. Again, those strategies you should have pretty well assimilated in your repertoire of being able to address quadratic problems. If it's a vertex form problem, you should be working backwards with the square root. If it is a factored form problem, use the zero product property. And if it's a general form problem, try to factor it. And if you can't factor it, use the quadratic formula. I think this problem you're going to see, it's going to be a quadratic formula problem when we get down to it. So let's take a look and see what it says. It says here, suppose that you had a 12 by 14 area. And suppose you wanted to increase the area by increasing the length and width by the same amount so that the area was doubled. Write and solve a quadratic equation that represents this scenario so that you find the amount you increase the length and width. Round your answer to the nearest tenth of a foot. Okay, so the one thing we need to do here is draw a representation of the problem. And I'll start with drawing a 12 by 14 area. Okay? And then we've got to make sure we understand the problem that's being described here. Okay? Where it says, suppose you wanted to increase the area by increasing the length and width by the same amount. Well, that would allow for me to take this base of 14 and extend it, and then this base, this height of 12, and extend that. But if you notice when it says by the same amount, what's key there is understanding you don't know that amount, but it in fact is the same amount, so I'm going to call them x. X is amount of extension, which again is what you're finding in the problem. So when we solve for x somewhere, once we set up an equation, we're going to be fine. So I guess you should be able to visualize that from here, you've created a new yard. Excuse me, a new area. I don't know if it's a yard or whatever it is. Okay? And what we're saying here is that this new area, the whole thing, needs to be the original area here doubled. Okay? Well, from that, you know the original area is going to be 12 by 14. So you know that the new area equals 12 by 14 times 2. Okay. So from here, we're going to have to make a quadratic equation somehow. Well, it's very simple when we say that the area is equal to the base times the height. Okay? Because we do have an expression for the base right here. If we notice, it was 14 and x more. Okay, so we see that this is going to be 14 plus x, and the height similarly was 12, but then extended by x, so it's just going to be 12 plus x. So we're going to say that the area, which has to be 12 by 14 times 2, is going to be equal to the base, which is x plus 14, times the height, which is x plus 12. Okay? Now from there, I hope we see that this is going to be a quadratic because we've got two linear binomials, and when I FOIL it out, it'll create a quadratic equation. So let's start to do some simplifying here and some re-expressing. And the first thing I'm going to do is take 12 by 14 times 2. And see that that is 336. And that is going to be equal to what this problem FOILs out to be, which will be, in fact, x times x is x squared, x times 12 is 12x, 14 times x is 14x, and then 14 times 12 is going to be 168. Okay, so I'll just clean that up with the like terms a little bit and see that I'm going to get 336 equals x x squared plus 26x plus 168. Okay, and then I will now take a look at this and try and make a decision on what type of solving I'll do for this quadratic equation. Again, I kind of run through the battle plan. I'm not going to be able to work backwards with the square root because I have a squared and a linear term. I can't use the zero product property as is because it's not factored. And that takes me to take a look at this. Well, this is kind of general form, but it's not equal to 0, so I need to adjust that by subtracting 336 from both sides. And that is going to give me 0 equals x squared plus 26x minus 168, I believe. I'll just check that on my calculator. 168 minus 336 is negative 168. Okay? And then say, well, this is a general form quadratic. How should I be solving that? Well, first thing I should do is try to factor it because that's always the quickest. Okay? If it can be factored. So what are the factors at negative 168, whose sum is 26? So I go to my calculator and do the little factoring trick, and I just scroll up because the bigger factors have to be positive. Looking for factors whose sum is 26, and I'm not seeing any. So this lends itself to a quadratic formula problem. Okay, so I'll move into that routine. I'll say A is 1, B is 26, C is negative 168, and from there I get x equals the opposite of 26 plus or minus 26 squared minus 4 times 1 times 168, all divided by 2 times 1. Okay? I'm looking to simplify just in that sort of triangular portion that I just kind of highlighted there. Is if you're simplifying that way, you're using good PEMDAS. So negative 26 plus or minus the square root of, going to my calculator, no shame in that, for 26 squared minus 4 times 1 times negative 168 is 1348. Okay, and then second square root, second answer, allows me to say that that's 36.7. X equals negative 26 plus or minus 36.7 over 2. And then I'll split the problem from there. Negative 26 plus 36.7 over 2, and negative 26 minus 36.7 over 2. And then just going to my calculator for these pieces, making sure I use parentheses for the top quantity in the numerator, divided by 2. My first answer is 5.35. And my second answer, just by hitting second enter, is to go back and change the plus to a minus and get negative 31.35. Okay? And then I've got to apply some logic here. If we've said that x is the amount of extension, the notion of it being a negative number makes no sense. So we'll cross that number out. It says to round to the nearest tenth of a foot. So this would make our answer x equals 5.4. So you should extend, excuse me for 1 second, just kind of make this a little bigger so you can see it on the screen. Extend the yard's dimensions by 5.4 feet. Now again, this just makes the length 5.4 feet longer and the width 5 feet longer, or synonymously base times height, depending on how you look at it. Okay, so what is the overview of this problem? The overview of this problem, excuse me, second, wrong button. The overview of this problem, again, is to be able to draw the appropriate diagram of the described rectangle, and then be able to make sure that you can turn that diagram into the appropriate algebraic expression, which is quadratic. and then apply the quadratic battle plan that lets you pick the method for solving that quadratic. In this problem, it was the quadratic formula, and then be able to find the answers from the quadratic formula and throw out the answer that was nonsensical. In this case, it was the negative value for the area, the extension on the dimension, and then be able to translate your answer appropriately. So enjoy. I hope this is a good example of using quadratics and traditional word problem strategies together to be able to solve this type of problem.